Welcome to the Connect with BMC Helix webinar series. During today's event, you're able to ask questions of our panelists. The questions and answers, along with today's broadcast, will be published to our channel. Today's topic is planning for Innovation Suite Containerization, and Alejandro Vidaurri will take us through this content. Over to you, Alejandro.
Thank you, Greg. As mentioned, my name is Alejandro Vidaurri. I'm a senior product developer at BMC Platinum Engineering, and in today's presentation, I'll talk about how to plan for Innovation Suite Containerization. In today's agenda, we'll have the overview. We'll talk about the top 2 questions we'll answer today. There are several feature updates that provide foundational changes aligning better with container philosophy and management. During the planning stage, we'll cover what resources, from technical to experience, and what path to follow to properly plan a containerized solution. While at the architecture and installation process stage, we'll showcase how the installation happens and common areas that will improve the installation experience. Finally, the references section will provide further resources to successfully plan a 2105 installation. The first question we'll address throughout this presentation is, why containers? In previous on-prem versions, deploying even a small solution like Action Request System and mid-tier required running an installer in multiple computers, and even if scripted, it required externalized coordination to ensure computer resources, connectivity, security, and consistency. Increasing the variety of applications, for example, to Digital Workplace Catalog, Smart IT, and others, increase the complexity and coordination efforts. The solution for this type of situation should be able to orchestrate the automatic deployment for diverse applications, scaling and managing them in discrete units. All these responsibilities are covered now by a Kubernetes cluster. Kubernetes manages a set of nodes as a single cluster, while understanding what needs to be deployed, the preferences of such deployments, the required connectivity between services, and the scaling needs, and executes all that with audit trails and role-based access control. All this provides the benefits such as faster deployment, better resource management, and increased environment consistency. There are less concerns about the operating system where the cluster runs, whether it's on-prem or on a supported cloud provider. Above the Kubernetes benefits, BMC installation process is automated most of the way, ensuring all the required information that links services together in the form of ports, service names, passwords, or certificates are properly interweaved. Building this type of solution may be feasible without Kubernetes or containers, but the high level of standardization provided by Cloud Native Computing Foundation project and other initiatives make containers the best approach. With all these benefits, there are important changes in the way a BMC solution is installed and therefore planned, which bring us to the next question. What are the skills, the hardware, infrastructure, and coordination efforts to plan a 2105 installation? We understand all the technology would only provide success if the right talent is behind it. That is a reason to put human resource education first. There are industry standard components involved, but the explosions of technologies can make it daunting to select and prepare on the ones needed for BMC particular solution. The hardware sizing is considerably different from previous versions, as we're thinking on multiple computers working as a cluster. It will also involve some external infrastructure. We'll talk about the external infrastructure needed to highlight the coordination efforts recommended for prompt enablement. On the education side, we need to acknowledge the technology our IT departments and remedy administrators would need to handle, or at least be aware of them, to get the proper level of specialization. To start, the container technology we've selected is Kubernetes. It builds upon 15 years of experience running production workloads at Google, then made available to public almost a decade ago. And while it would be advised to get certified in Kubernetes to properly handle and troubleshoot aspects of it during installation or at runtime, a common question we've heard from customers is, what level of knowledge or hands-on experience would be required for Kubernetes or other orchestrators? I'll mention a few of the common tasks. Definitely installing a cluster and making sure the connectivity between the controller nodes and worker nodes works fine. Making sure you can deploy objects in containers and adjust its configurations. Provisioning the disk space known as volumes that will be mapped on Kubernetes as persistent volumes or persistent volume claims. Ensure the connectivity from outside networks to containers, as this will involve external networking coordination such as DNS, external load balancers, and knowledge about Kubernetes manages for external access toward services. This is called ingress controllers. And as a very good tool, we recommend curl command. It's a very nice utility that will make HTTP requests, and it's of great assistance and almost always available in Linux environments. Hopefully this clarifies the level of knowledge or experience required for Kubernetes. Now, regarding what type of container orchestrator is preferred, a vanilla Kubernetes cluster is certified to work with 2105 Innovation Suite with version 1.18. However, other cluster solutions are feasible and provide the richest experiences towards managing a cluster. For example, OpenShift 4.6 is also certified to work with this BMC solution. Other technologies such as Tanzu and Ratcher are not yet certified, but we are working with them. As part of the installation process, we will need to create multiple configuration files and make sure the infrastructure and other resources are available as we progress throughout the installation. Jenkins, previously known as Hudson, is an automation server that will help on this topic. Even though we provide documentation and step-by-step instructions, first-time users of Jenkins have found a significant distance from previous BMC installer experiences. Getting used to its interface, its design, and interaction model is definitely recommended. In previous versions, software was delivered as binaries, virtual machine images, or compressed files. Now, it is delivered as container images. Those images are published through repositories, and customers would have access to BMC, Docker Trusted Repository, or DTR in short. However, for customers that at installation time would not have connectivity to BMC resources, the option to install their own repositories exists. This would be hardware component in its version 2.1.4. Other tools such as Grafana and Kibana are now industry standard. They provide robust ways to interact with various data providers, build queries, and publish dashboards among other artifacts. Customers that have experience with them will reuse their own knowledge and lower the learning curve. On top of Grafana and Kibana, BMC has added values to fulfill Innovation Suite or autonomous digital enterprise tasks with both of them, and they are documented at BMC sites. Lastly, three key components that will be part of ADE, Autonomous Digital Enterprise Common Services, are called Kafka, which is a high throughput, low latency system for handling publisher consumer streams in real time, Victoria Metrics, which is a time series database and monitoring solution optimized for high cardinality, and Redis, an on-memory key value database, cache, and message broker. And even though these components are accessible, most of the work done on them happens through the installer and managed through ADE actions. A comprehensive list of involved technologies is provided as part of BMC documentation and references architecture. As part of the education efforts, please review bmc.com/education and speak with an education advisor. There are multiple resources in there, such as the ones on the screen, that will help improve the speed and robustness of adoption. On the other side, BMC is also working internally to have certified Kubernetes administrators in diverse internal teams, with the goal of having successful implementations and troubleshooting sessions when needed. Now that we've covered the technologies leveraged for Innovation Suite Containerization and the technical skills needed, let's move on how products have bridged the gaps to be optimized for containers. For the administrations of Action Request System, Digital Workplace, and Innovation Suite, having 3 separate servers can be daunting when moving into containers. To lower the complexity, instead of managing 3 different servers, New Innovation Suite Server is a single binary that involves ARS, Innovation Suite, and DWP Catalog Servers. This helps in resource service allocation and ensure all instances provide the same 3 services. Regarding storage and logging, let me describe a scenario where moving out from having 2 mid-tiers to 4 or 10 could happen in the same day. In previous versions, the cache storage and statistics were handled by each mid-tier. Therefore, they ended up holding its own cache and eventually have duplicate content. In order to improve resource management, the cache for mid-tier is now stored on Innovation Suite Server database. And if a new mid-tier comes online, it will request the cache to the AR server. This will also maintain cache statistics aligned across all mid-tiers. Regarding logs, there are 2 techniques involved. For Innovation Suite critical logs, they are stored in Elasticsearch, a Lucene-based storage, indexing and search system that will help retrieve logs, analyze them with its own user interface named Kibana. On the other hand, for well-known remedy and platform logs, they are stored on each container called a pod. This represents a challenge for operations that would need to retrieve the logs, unsure of where are those logs and how do I retrieve them. And even though the cluster provides a way to fulfill this task, it is usually out of remedy administrator scopes or skill set. To allow easier and faster log retrieval, BMC has developed a service called Support and System Tool that provides a graphic user interface to retrieve logs from different containers. On the full text search, FTS front, BMC has changed the storage system from a pure Lucene backend to an Elasticsearch one. This allows better scaling, disaster recovery, high availability, and other features. Now, as BMC strategy is to provide our customers with a single service and operation management platform called Autonomous Digital Enterprise, aka ADE, we have its common services as part of Innovation Suite 2105. As a tenant administrator, you can use ADE's common services to set up role-based access control from a single place without the need for multiple configurations across products. You can access the common services from the user access menu on the BMC Helix portal console. Now we're aware of some of the important changes and additions on Innovation Suite components for better alignment with container principles. But let's look into how to size your hardware. The hardware may be provisioned in a classical way in your on-prem installations as bare-bones hardware boxes, local virtual machines through ESX, and also cloud providers such as Amazon AWS, GKE, Azure, or IBM Cloud. Some cluster orchestrators such as OpenShift may need special grants on ESX, so please check out our documentation on this topic. Currently, we offer sizing services through sales and engineering process. This process will provide preliminary data, and the reason behind this is the final numbers will be available around 3 weeks after general availability, as our performance teams are still doing fine-tuning on them. The most important data that we need to size your environment would be the number of concurrent users your new Innovation Suite will host, and the type of resilience considerations you would need. Would you have all or some of your environments with high availability mode? would you need disaster recovery environments, and all that. Finally, some optional components that may not be required, such as Smart IT or live chat, depending on your needs. Once we have all that information, we'll process it through our sizing models and provide recommendations split in 4 sections. How much hardware would you need for controller nodes, for Innovation Suite worker nodes, for ADE worker nodes, and the deployment manager node. For high availability environments, we may recommend multiple worker nodes and multiple controller nodes. In this slide, we'll showcase the sequence of installation. All the components will be displayed as we move along building the final architecture diagram. After reviewing the hardware provisioning, it is important to understand the sequence that will go through the installation process. Let's start with this. We know it looks almost like a white canvas, but we have 2 important aspects. The network, which should be able to access a BMC Docker trusted registry. We know this network could be an on-prem network or on a cloud provider, but this is the network where all the cluster nodes would share for internal connectivity. And besides that, it will need access to BMC DTR. There are a couple of scenarios that may put the connectivity in question, but let's take a look at them. If DTR access is available only before installation, then installing hardware and synchronizing it with BMC DTR is needed. Then the installers will retrieve and deploy images from a local hardware instance. On the other hand, if DTR access is available during installation, setting up hardware is optional and images will be pulled directly from BMC DTR. For completely air-gapped environments, this gap should be breached at some point, with one hardware having access to BMC DTR in the DMZ, the militarized zone, and the hardware in the air-gapped network with a proxy server in between. In some situations, due to network traffic or connectivity issues, it is preferable to have a local hardware already synchronized before starting the installation. The next aspect that we would need is the database server. And we need to make sure that you have either an Oracle database, a Postgres 13 version, or a Microsoft SQL server. This database should have connectivity with your cluster network. And in this cluster network, you should provision your hardware. On top of your hardware, we would need an operating system for that cluster orchestrator in any x86 Linux version that supports Kubernetes 1.18. And on top of that, a bash shell that is 4.2 is supported. Deploying the cluster orchestrator can be done at this point with either Kubernetes 1.18 or OpenShift 4.6. The result is that kubectl command line is available. Communication across the clusters should be ensured. The command issue. When you issue a command through Kube API server in the form of kubectl, they will go around these lines. The API server will receive all the requests to update the cluster and at the same time interact with the internal registry called etcd. And in there, it will register all of those changes in its distributed database. The API server will also interact with each node through a kubelet and kubeproxy to execute any changes. The scheduler will be invoked to program these changes in the adequate sequence. And once all the changes have been applied to the cluster, the final state is recorded back to the etcd database, including all the unwanted events. An important piece of setting up the cluster is the ingress controller. OpenShift requires additional setup to install the ingress controller. And having control over ingress will allow customized domains when needed. At this point, we will need to set up the deployment engine and the deployment manager. The deployment manager is needed to set up the ADE Common Services component. Once downloaded from EPD sites, it would require information such as the DTR servers and credentials, which may be BMC, One, or Harbor, load balancer hosts and ports and external domains, default tenants, SMTP servers, storage classes, which we'll talk a bit in a while, binary paths for utilities such as Helm, kubectl, or OpenShift client. The deployment engine is needed to install Innovation Suite, and deployment engine will require several libraries, tools, and a Linux user setup. The list will include Python, Git repository that BMC will provide, Ansible libraries, Helm, and Docker. One key component in the deployment engine is a container running Jenkins. Jenkins works in the concept of pipelines, that is a set of steps to perform an installation. The pipeline steps are delivered by BMC, and we'll need to tell Jenkins where those configurations are. Each pipeline will perform the installation of a different component, but also it will interweave the results of those installations and preconditions to move forward in the sequence of deployments. There are 10 pipelines that will run in sequence, and to input all the parameters there are two ways. One through a script file, text-based, and a second one through Jenkins user interface. The Jenkins container will receive inputs such as the cluster information, database information, library paths, DTR services, URLs for multiple service, mid-tier, and REST, Git repository locations, storage classes, number of replicas for each of the pods that will run, and memory settings. Reviewing the full list of parameters needed in the documentation is highly recommended. At this point, we're not executing the installation yet. We're only laying out what is needed. Disk space that needs to be handled in a different way that is accessible to the whole cluster. The abstraction for this is called persistent volumes. The recommendation is that persistent volumes are handled with block storage system such as Ceph. Other options may be useful for POCs such as NFS, but they are not yet certified. A DNS would need to respond to multiple domains depending on your configuration. By default, we are talking about 16 domains. Having an adequate DNS records to direct traffic from either 16 domains or subdomains is recommended. One technique we use is having a single domain record in DNS and configure all the services as subdomains. But please coordinate this effort with your DNS and load balancer administrator teams. An external load balancer has the responsibility of doing SSL offloading and forwarding the traffic to the Kubernetes cluster. Additionally, the load balancer needs to inject two HTTP headers, x4.4 and x4.proto, and special routes or access for non-HTTP traffic may be needed to connect Developer Studio or API integrations to the Innovation Suite servers. At this point, we have all the information to start the installation with Deployment Manager. The result of this installer will be reflected in the form of the ADE platform common services, including tenant management system, tenant automation system, identity management system, Helix portal, and an instance of a single sign-on. Once the ADE common services install is successful, we can proceed installing with Deployment Engine. Innovation Suite Server, serving the responsibilities of previous AIR Server, Innovation Suite, and Digital Workplace Catalog will be accessible through its multiple web clients, such as Mid-Tier, Smart IT, Smart Reporting, DWP, etc. Different instances of Innovation Suite will be deployed, such as administration ones, user accessible ones, and integration. While performing the installation and depending on your database vendor, the Innovation Suite Smart Reporting databases will be created or populated. After these, the user tier will be able to start using the platform, and your Innovation Suite will be functional. In the previous slide, we've talked about the installation sequence and how the architecture is conformed. However, there are some components that may not have a clear graphic representation that need special attention. Please plan for these items ahead of your installation. The database externally hosted will allocate for Innovation Suite and Smart Reporting database. Consider that 2105 Innovation Suite database now hosts databases previously known as the Azure Server database, the Digital Workplace database, Digital Workplace Catalog database, Smart IT, and the former Innovation Suite one. And therefore, its sizing considerations will be different. The Exchange server is needed during installation for notification purposes. And even though the installation can finish without sending notifications, you may see errors in the logs when messaging fails. The DNS, load balancer, and SSL certificate are crucial, and the installer will make requests to actual host names and ports. If any of these requests do not receive a valid 200 status in response, the installation will report those errors and stop. On the cluster side of the prerequisites, access to BMC Docker registry is needed at some point, even for air-gapped networks. The images will be pulled by both Deployment Engine and Deployment Manager. Having reliable connectivity to BMC DTR is recommended at installation time, but if that is not feasible, setting up your own harbor and synchronizing it with BMC DTR is advised ahead of the installation. In some situations, a floating IP can cause disruption in the cluster. Therefore, the recommendation is that all your cluster nodes have static IPs. Communication ports should be open for Kubernetes API control plane, such as port 6443 and others, but please review our documentation for all the ports and protocols that our BMC products use, and make sure all that communication is granted. Regarding the installer process, well, there's a significant user interface change. In previous BMC product, the installation followed a customer interaction model. Individual screens were provided in a sequence to enter small pieces of data. Then validation will happen as you move forward. If the validation failed, you would enter fixed data by moving back. And if the situation happened at the very end when the installation was executed, well, you may get a log. Now, in both 2105 Deployment Engine and Deployment Manager, the interaction model of the installers is different. You may use configuration files or the Jenkins user interface. Now, if you use scripting, well, the validations will happen while the installation is run, and all the feedback will be available on a log or on the screen. With Jenkins, the validations would happen when the pipelines are deployed. And if you have any issue, you would need to review those logs, modify the values, and then rerun the installation. Jenkins is prepared to deploy multiple pipelines in sequence, and of course allow you the possibility of change values between runs. As this is a web-based application, other colleagues and teams can inspect the logs to find out any solution. On the other hand, if this is a new interface for you, well, it has its own learning curve. Please take the time to familiarize with Jenkins and user interface philosophy. I'll show some of these aspects during the demo. Now that we've covered most of the planification, the installer summary looks much more simple. All the hardware provisioning and external services would be part of the prerequisites. Through EPD, you would get your Git repositories and the tokens to access BMC DTR. Harbor may be needed, but please consider it also as an alternative if you have an inconsistent connectivity to containersbmc.com during installation. ADE common services are a prerequisite for Innovation Suite. Deployment engine and the libraries will conform an environment that will be used to deploy your Innovation Suite pipelines. All the pipeline installation can be done by scripts or by Jenkins UI. And after the pipelines are successfully deployed, you need to perform some post-installation procedures, such as licensing and importing certificates for third-party integrations. Finally, what's in store for migration? In order to plan a migration to 2105, you should have one of the versions in this slide and also consider the source and target database vendors. Please route your interest to migrate to Innovation Suite Containerization through support amigo cases. Now let's jump into a demo. During this demo, I want to show some of the aspects that may be daunting or different. First of all, when we're in EPD, you see this Docker icon. This Docker icon indicates that this is your gateway to get to the Docker images. So when you download this file, you would get the Git repositories that your pipelines will need, but also the access token to get to BMC DTR. So once you download it, this contains not only the software, but again, crucial information to get access to BMC DTR. Then I'll go through some of the Jenkins user interface. This is one of the most complex situations because you're setting up pipeline. A pipeline is simply a set of instructions to install an individual component. In this case, you would see that we're about to deploy Helix, the single sign-on. And in order to configure the pipeline, well, you need a particular repository URL. So this repository URL is basically a decompressed zip file that we provided in the previous EPD screens. And you should have an absolute path to it. So if you go into your particular system, you should have this path as an absolute way to resolve. Let me just show you that. I'll go into that, fold into that, and simply say, hey, I want to do a list of that. And that will return some of these files. In some situations, we've seen that the path entered maybe starts at Git repo, but of course, if I don't have that directory, well, that's going to cause some issues. Now, the second aspect of it is what type of connection is done to that repository. And in here, we're implying with the type of URL that this is going to be an SSH connection to a particular host using a certain user, in this case, Git. So please make sure that you can run those commands, and I'll show you that. So first of all, the command that will help you make sure that you have access to that would be git ls remote. And of course, I'm running it locally on this file system. Now, let me copy that and go back to another server, which is the one that's going to make this connection. And let me do logging into the Jenkins container. Once you log in, you see that your prompt will change, but there are not other visual indicators that you're now in the Docker container. I'll exit that and join again just to showcase that difference. Well, now I'm here and I want to do a git ls remote. This command git ls remote is going to help you verify that path. So I'm going to create an error here, and it simply say, well, this directory does not exist. This repository does not exist. Now, if I fix it, well, hopefully I get the information back. But please, if you get any errors with this type of connection, the usual troubleshooting technique goes into, well, making sure you can do an SSH connection to this host using this user. So I'll try doing that. Using the V option at the end with SSH connections is very useful, and we'll see that it's not even asking for a password, and it's providing a set of keys in here. Let me see if I can show you that. It's setting the keys. So that's the key. And that's the option to send a key. And this is my client, my SSH client is offering the key stored in this path. Then it says authentication succeeded. So, well, with this, we want to highlight the multiple aspects of building this type of string. Of course, the documentation talks about it. Now, let's go into Jenkins pipelines. So once you configure all your pipelines, you would see something like this: Helix RSSO deploy, platform deploy, and all that. But once you start running one of them, you would see multiple aspects of it. One is, I've run this 17 times on this server. And if I need to go to one previous run, well, I can go to any of these and simply say, well, for number 5, I want to see what the log had in mind. And I can scroll through it and see some ancillary stuff happening on Jenkins, but eventually we'll go into the commands that are being executed. Well, and there it is, that git ls remote command. Of course, you can traverse through all that, and every of these URLs are unique. So if you need to get assistance from any colleague or even from us, well, having these URLs handy is going to be very useful. Now, let me go back to, and of course, all my runs are there. If you see something successful, well, it would look like this, all greens, and it will showcase every single step. But let me show you something that was not working completely. It's going to show every individual step and eventually something that failed. For example, my run 32 failed here, and these others were aborted at some point. So I want to investigate what happened there. So I'll go to this link and say, well, go to the console output, and this will have a link at the top that says full log if I want to see everything. My recommendation would be just scroll all the way to bottom. Of course, my expectation, because it failed, is to see that message here. But if I start scrolling up, I see, well, it went into another pipeline and tried to do a deployment. And after that, well, I see exception. And well, my SMTP server is not properly configured. So it said I could not notify you properly. But before that, it seems to be working fine. What this means is the initial pipeline for Helix On-Prem deployment was running, and it tried to, as the sequence commanded it, well, it tried to go into Helix platform deploy, and well, that's when the situation happened. So I'll click into that, then go into console output, and of course I still have that full log available. So I'll scroll all the way down and move forward and move up. So I see the exception occurred here. That's fine. But what's the previous? Okay, it's saying that I'm going to be able to find a full log zip file there. And the purpose of this presentation is not to do troubleshooting on what the error was, but help you navigate through Jenkins UI so you'll have some items covered before you actually have your own Jenkins server running. Well, that's the end of the demo. In this reference section, we want to highlight that please use our detailed documentation. The BMC educational resources can help to get up to speed in BMC products. And regarding the certified Kubernetes administration courses, we know there are several out there. The one listed here provides great theory, graphical experiences, and hands-on labs without the need to install your own environment. So you don't even need anything to go through this course. The Kubernetes administration certification would give you really great insights and tooling to handle your cluster. So we cannot recommend it anymore. As mentioned earlier, well, BMC is also making sure certified personnel is available at several BMC teams. In summary, well, we know 2105 platform relies on containers that are orchestrated by Kubernetes or OpenShift. This requires some new skills, ways to provision and set up your hardware, and of course, coordination efforts. Having a Kubernetes specialist available during all the planning and installation process is highly recommended to ensure all the cluster prerequisites have been met. The installation process, as you've seen, involves some Jenkins understanding. And of course, BMC is committed to make your installation a successful experience. So please let us know if you need any assistance during any stage. That concludes my presentation. Back to you, Greg.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is listed here. It contains past webinars as well as a rich set of how-to videos. The Connect with BMC Helix ITSM and Remedy webinar schedule is available at this community's link, and the hot off the press newsletter for trending information is available at this community's post. As always, contacting technical support via web, phone, email, and these social channels is available. At this time, that will conclude this webinar. Thank you for attending.